polynomials.
Uh, Domain and range of polynomial means?
Like there's a lecture like 4.3 in that
Mhm.
sir have explained something domain and that range.
Okay, so are the concept clear to you? Domain and range? What else? Like, what do we mean by domain? What do we mean by range?
Yeah.
And how to
Yeah, I
calculate it?
know.
Okay, so these
Yeah, I
concepts
know.
are already clear, right? I mean, if you have any doubt, you can ask. Huh?
Like for the set now, we can imagine like, yeah, this is the domain, this is the codomain and the range. And
Yeah.
for quadratic, it's like it's also.
Mm-hmm. Okay. So, like in short, domain means set of all inputs where the function can be defined, right?
Yeah.
And a range is basically with the collection of all possible values of the function.
Yeah.
Domain
Right?
is the input
So,
and the range will be the output. No,
can you bit little louder? I
no, no,
couldn't
no,
hear.
ma'am. It's like domain is like the input and the range
Yeah,
is what we get the output. No, ma'am.
yeah, yeah,
When
yeah,
it comes under the polynomial, no, ma'am, they will relate with the graph. No, ma'am. So that is the
yeah.
area little bit need more assistance, ma'am, in this concept of Week-4.
Yeah, yeah, I will cover all the concepts. So when we draw some graph, generally we use this Cartesian coordinate system, right? Where both the vertical and horizontal line represent the, I mean the x-axis and y-axis. This basically represents the whole real number, right? The set of all real number. So this is clear,
Yes,
right?
ma'am.
Yeah, this is one like
Yeah.
the y-axis is set of a real number and the x-axis is also set of a real number. So we generally we consider the x-axis as our domain when and the y-axis as our codomain or range, right? So when we draw some like graph like that, that means we generally take the points like x comma fx, right? Where we take the x coordinate, that means this x axis because it is domain. So we take the x coordinate from the domain, that means from the x axis, and then we take the functional value at the point as the y coordinate, right? So which is basically part of the domain. Right. So here, suppose this is a point over the graph, right? That means we have these 2 points, right? So this is the point in domain X and this is the point in codomain Fx, right? So when we put these 2 points together as a x coordinate and y coordinate of a point in a Cartesian coordinate system, then we can get a graph. So these are the easy concept. These are already clear to all of you, right?
Yes, ma'am.
Yeah. So in week 4, so here we are going to cover all the week 4 content. I will cover concepts and you can stop me immediately and ask your doubt if you have some. Okay. So we started with polynomials, right?
Yes, ma'am.
And
Yes,
yeah,
ma'am.
the general we can denote it with px. Polynomial is basically a kind of function of x and like that means in one variable. So this is we can express it in that way, right? This is the general expression of a polynomial. So we can also write it as a naught plus a1x plus up to an xn, right? So this equation can be also like written in this form as a summation of I equals 1 to n in general version, right? So whenever we are, because here we are talking about a polynomial, we know that the exponent should be a member of natural number, right? Right? That means
Yes.
here our set of all natural number is from 0 to infinity. Okay, and the coefficient, these are called coefficient of the polynomial. These are basically member of real numbers, right? Because we the polynomial p. So for the polynomial p, so wait for 1 minute. Okay, so let us begin again. So what were we talking about? The exponent of polynomial and the coefficient of the polynomial, right?
Yes, ma'am.
Yeah. So we know that the domain of P is the real number and the codomain is also set of a real number, right? So we take some real number which is x from the R, and after applying P we will again get a real number. So in order to get a real number, we definitely need the coefficient as a real number, right? Because if suppose if we take the coefficient as some complex number, then after multiplication we may not get real number, right? So that is the reason behind the coefficient to be a real number. Okay, so these are the basic definition of polynomial that we all know. Then we know about the arithmetic operations of polynomials, right? Like addition, multiplication.
Here I would like to have a doubt, add my doubt.
Mhm.
Is
Yes.
zero a polynomial, only the integer zero,
Yeah,
or a monomial, can we say?
yeah, we can say.
But the degree of zero is
In
not
fact,
defined, right?
yeah, yes. Zero is a polynomial, but degree is not defined. Is a like it's a constant function, so it's a polynomial. Just if we take some px equals to a naught, we can take in a zero instead of a naught. Also, we can take an, like instead of an or like anything, we can take zero. So zero is a polynomial, but degree is not defined. Yeah, you are completely correct. So any other doubt?
Yes, ma'am.
No, ma'am. Like you can.
Ma'am,
My doubt is clear.
I also want to ask one doubt. For example, we have an expression like 2x square plus 0. So,
2x
uh,
square 0.
so ma'am,
Okay.
yes, ma'am. So, we'll consider it to be a binomial, right?
No, this is a monomial because this is basically 2x square, right?
But ma'am, just now you said that 0, like we consider it to be a polynomial. I mean, it is also 0 polynomial we consider it to be. So, I think it should also be counted as one of the terms of this expression.
Um, I don't think. I mean, it this if this is true, then if we have any polynomial, we can add several zeros there, na? Then like any polynomial, any monomial, any binomial, suppose we have, then we can make it polynomial, right? With adding zeros.
Then there is no value for zero, right, ma'am? Then
Yeah,
zero can't be counted as monomial. Right?
no, like if we have some like y equals to 0, then it is like possible. Like if we have only the 0, but if we have something added with zero, what?
Someone has unmuted by mistake, I guess.
Okay.
So that means, ma'am, if we have a single zero as a function like y is equals to 0, then it will be considered as monomial.
Yeah,
But if
then
it
we can consider it. But if we have something added with 0, then we cannot consider it. Okay.
okay,
Otherwise,
ma'am.
any monomial, any binomial can be considered as polynomial, right?
Yes, ma'am. Right, ma'am. Okay. Thank you, ma'am.
Yeah. Okay. So, yeah, is there any other doubt? Mm.
No, ma'am, you can continue.
Okay, so let us continue. So, yeah, we have arithmetic operations. So, mm, we know how to do the arithmetic operations. Like, so if we have two different polynomials, suppose of degree n um, and q, another polynomial of just like of degree m. Okay. So if we have some polynomial like that, then we can like do the addition, the multiplication, the subtraction uh, with these two polynomials, right? So what will be the addition? Any one of you can unmute yourself and say what will be the addition of these two polynomial p plus q.
Summation of
Mhm.
hello.
Yeah, yeah.
I don't know like what is called that VMVN, the upper limit, and
The
k is
biggest in
equal to
M or
0.
N, the degree which is big in
Yeah.
M or N. So we will take unions.
Mhm. Union.
Yes, ma'am.
Okay, okay. Let us first talk about the degree of the
Maximum,
polynomial.
not
So,
union.
yeah, so what will be the degree of p plus q?
It should be the
The
M
maximum in
is
M or N,
N B M. N maximum is B and M.
Yeah. So it's basically the maximum of m and n, right? The degree of p plus q is. That means basically we know if we want to do the addition, then we have to compare the term, the coefficient of the term with same exponent, right? So if we have, suppose for example, a naught plus a1x and q equals to b naught plus b2x square, then we cannot add this two because here the coefficient is 1 and here the coefficient, sorry, exponent is 1, here the exponent is 2. So we basically need to take the coefficient from same like exponent power, right? So here the addition will be some a naught b naught plus a1x plus b2x square, right?
Yes,
So
ma'am.
from this example also we can observe that the degree of the like polynomial after addition is the maximum degree, which is 2, right? So similarly, if suppose like m is greater than n without a loss of any generality, then we can express this polynomial p as a1 plus dot 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 a n x power n plus 0 into x power n plus 1 plus up to 0 into x power m, right? Then we can do the addition. Now we have both the term of up to degree n, en x power n, right? So the addition will be ai plus bi x power I, where I equals to 0 to maximum of m comma n, right?
Yes,
So
ma'am.
yeah, so we can consider this in this way. And what about subtraction? So subtraction is generally a particular case of addition, right? So that means if we have a polynomial p p, then minus p is also a polynomial, right? Because we are just multiplying all the coefficient with minus. So it will be again a real number. So minus p again a polynomial. So if we just add q and minus p, then we can get the subtraction q minus p, right? So subtraction are just a particular case of addition. And what about multiplication? Okay. So if we have same p and q, what will be the degree of pq?
Addition of the degree of
M
P
plus
and
N.
Q. N plus N, that's.
M plus n.
N plus n, right? Yeah. So how do we do the multiplication if we have this? In the case of multiplication, we generally consider all the terms, right? That means the constant term plus, then we will consider the coefficient of x. So in this way, we will get all the terms, right? At the end, we will get a n b m x power n plus m, right? So
Yes,
if
ma'am.
we want to express it in a general form, like in something in short, so how can we express it? A naught, B naught is fine. How can we express this coefficient? Let us start with some small thing first.
Hello.
Yeah.
Yes, ma'am.
Ma'am, can you repeat this multiplication?
Yeah, if we do in case of multiplication, we will do the term by term. Like we will multiply all the term of Q with all the term of Q. Okay. So then we will get this type of form. Okay. So after the constant term, we need to check the coefficient of x. So what will be the coefficient of x? When we multiply a naught with a1, then we will get one x1, x there. Also, if we multiply b naught with a1, then we will again get a x there, right? So if we take x as common, then we will get this as the coefficient of x, right? So how can we express it in a short term? Yeah. Oh, look. Do you want to say something? Yeah.
Yes, ma'am. Am I audible, ma'am?
Yes, yes.
Ma'am, I am able to do any operations on polynomial, right? But I am not able to understand this standard form like a n x raised to the power n. Is this necessary for know about the standard form?
I cannot hear you. Can you repeat your
Ma'am,
doubt?
are these general form which you are telling us to write, like this summation, etc.? Are these important for the exam point of view?
Okay. If you
Because
consider,
I'm able to do all operations.
okay, so yeah, these are important
I have no any
from
skill
the
level.
exam point of view also. Yeah, I'm answering your question. So these are important because yeah, sometime you need to do the calculation using this term. So you may not be like, you may not get that much time to write whole the term. So in that case, you may have to write it in a something shorter form. So it is nothing tough, right? So you can be comfortable with the thing. So
Yes, ma'am, the multiplication part is easy if we do it, but we are saying about we have to memorize the standard equation. Because this the question which you are telling us, it is in the assignment also.
no, not need
The
to
standard
memorize
form.
it. No, not need to memorize it. You just need to understand how these are coming. Okay. So,
Yes,
like,
ma'am.
there are some assignment questions from this type of thing, right?
Yes, ma'am. There
So,
are.
yeah, in this
Yes,
case,
yes.
you don't need to remember them. You just, like, you should know how are they coming. Okay.
Yes, ma'am.
Yeah, you should have the concept clear. That's it. don't need to remember the standard form.
Ma'am,
Yeah.
ma'am, this is the same portion we have read for qualifiers, right, ma'am?
Mm-hmm.
But the graded assignment sums were changed, right, ma'am? So when I was checking graded assignment answers, there is only the past answers available for graded assignment. Where you can check the answer for current graded assignment, ma'am?
So current graded assignment should be available in the portal also, right? There should be something called supplementary content.
Yes, ma'am, I have checked, but only past answers available.
No, this should not be the case. Past graded assignment, like what are you meaning by this past graded assignment? Like from the previous years?
No, ma'am. Just now I have completed my qualifiers. So this is the same portion I have read for my qualifiers. Right, ma'am. So
Okay, so if you are facing some problem with your portal, then like you can mail about it, or else you can ask Vishal also about it. Okay.
Okay, ma'am.
Yeah. Okay. So let us continue with the problem. So anybody, can you unmute yourself and just tell me how can we express this term in a short notation? Just one
Ma'am,
term.
can you explain
AIBI
explain the
into X.
What?
can you explain these terms from basics, because I'm not
Ma'am.
able to understand these.
Ma'am,
Yes.
Summation of I equals to 0 to n AB, ma'am.
ma'am, can you explain this term using example?
Yeah, sure. Okay. Let us do like write some more term. So a naught plus a1x plus dot a n x n. This is one of the equation, and the second one is b1x plus. So these are the polynomials, right? So we want to suppose do the multiplication. Then we will do all the term will be multiplied by all the term of q, right? So we will have this one. Then we will multiply all the term. Then the last term we will get is this one, right? Fine up to that?
Yes, ma'am.
Yeah. Then we will again take over the brackets. Then we will get these terms, right? A naught b1 x plus dot plus a naught bm xn plus, similarly we will multiply all the term and we will get this one, b naught xn plus an bm x power m plus n. Fine up to that?
Yes, ma'am.
Yeah.
Yes, ma'am.
Now we will calculate the coefficients. Okay. So here if we write just two more term, so we will get a naught so here there will be one term, so b naught a1 x plus some other terms. Okay. So if we just compare, the constant term will be a naught b naught. So there are no other possibilities for the constant term, right? Now suppose if we want to calculate the coefficient of x, then we will get a naught b1 plus b naught a1 x. Okay, so this is the coefficient of x. Similarly, we will just simplify this and we will calculate all the coefficients. Okay, then we will get the last term a n b m x power m plus n. So far, is it fine with all of you?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Yeah. Now, suppose if now we want to, okay, so just talk about this term. So, yeah, how we can express it in something shorter notation?
Ma'am,
Someone,
exponent
something
m plus n
equals
only
to
for the last term.
Summation of j is equals to 0 to k is equals j is equals to 0 to k, and
not
then
k. Here we will take one, right? Because we only have one.
we took
Two.
example here.
Yeah.
n minus
AI
A
B
to 1, yes.
I minus 1 x power I, right?
Yes, ma'am.
Sorry, x power 1, right? Okay.
Ma'am,
So, yeah,
m plus n is only for last term.
yeah, this
M
is
plus n.
this is the last term.
Okay, ma'am.
So, yeah, suppose we want to maintain this type of thing, then what can we do with the last term?
Then
Without loss
again,
of
we have to do
there is
summation.
something which is bigger, right? So suppose m is greater than n. Okay. So we can express this term an bm x power m plus n as equals to some like a naught b m plus n plus a1 b m plus n minus 1, where this b m plus n is 0 and this is 0. Okay.
Then we have to take summation once more, right?
Yeah. So the thing is, that is how we are getting the similarities between all the monomials, right?
Yes, ma'am.
Yeah. So this is the coefficient of this. Then we will again express it as j equals 0 to m plus n a j b m plus n minus j x power m plus n, right?
yes, ma'am.
Clear? Yeah. So up to that, it is clear. Now, if we just use another variable k, okay, and k suppose varies from 0 to m plus n, okay, then we will write these terms, okay, which is j equals 0 to k aj b k minus j x power k. Okay, so this is the multiplication. This is a shorter notation of a multiplication of these two polynomial. So any of you, if you are facing any doubt, you can ask. Is it fine? Is the term? What?
Ma'am, I performed the multiplication between two polynomials, but I don't do it with formula. So how it is used?
Yeah, that is what I did
Questions.
here, right? I did the term by term. Now, see, for the like first term, that means when the exponent of x is 1, then we are getting this term. Similarly, we will get similar type of term for every exponent up to m plus n. Okay. Then we are setting a different variable k, which is varying from 0 to m plus k, right? Then we are again expressing it in this way. Okay, if we just break this summation, then we will get this equation again with the summation of all the terms. Okay, is it clear now?
Yes, ma'am.
Okay. So, yeah, it is multiplication of polynomial, and that is how we can express it in a general formula. something short. Okay, then division. So if we do the division, so we will then get some polynomial, suppose capital Q plus R. So here this is called the quotient, right? And this is called the remainder, right? Right? So if the remainder is 0, then we will say that P is divisible by Q. And if there is something non-zero, then we will say that P is not divisible by Q, right?
Now explain once again.
Okay, suppose we have P and Q two polynomials. And suppose we want to divide P with Q. Okay. So if we get this type of thing, so if this R is equals to 0, then we will get this P by Q equals to some polynomial. This is some polynomial, okay? Then we will call that P is divisible by Q, okay? For your convenience, let us consider example. If we have 2x plus 1 and suppose Q equals to x plus 1, okay? Then what will be P by Q?
X plus 1.
Yeah. So this is x plus 1, right? This x plus 1 is a polynomial. Sorry, I wrote this Q will be there. Okay. Sorry. Yeah. So this is a polynomial, right? And then P equals to x plus 1 into Q, right? So we are multiplying a polynomial with another polynomial. Then this is again a polynomial. So in this case, we will say that P is divisible by Q. But suppose we have x square plus 2x plus 2. Okay. And Q is the same as earlier. Then what will be P by Q?
X plus 1 by Q.
Yeah, x plus 1 by plus 1 by Q, right? So clearly this is not a polynomial, right? For this term, this is not a polynomial, right? So we can again express it as x plus 1 into Q plus 1, where this 1 is polynomial, but we are getting this is our Q, this is our R, which is not equals to 0, right? In this case, we can say that P is not divisible by Q. Okay? Is it fine?
Yes, ma'am.
Yeah. So if we want to do the polynomial division, then factorization is a very good method. Yeah, Megha.
Ma'am, I have a doubt of a question.
Yes.
Consider a polynomial where px is equal to x square minus 1 and tx is equal to x cube minus 6x square plus 9x divides by px.
What? P by Q.
Divides px. Qx is the quotient when px is divided by the polynomial zx is equal to x plus 1 plus x sx.
X plus 1 plus
X sx.
fx. Okay. So this is a quotient. That means if we do P by Z, we will get Q, right?
Yes, ma'am.
Yeah. So what do we have to do with this? Like, what is the question?
Consider a polynomial. How to consider a polynomial? With the help of px, qx and remainder.
Okay, so you have two polynomials and now you can multiply it. Like then you have to calculate the value of f maybe, right?
Yes,
Is
ma'am.
this the question? Yeah. So x square minus 1 here you have, and here we have x plus 1 plus x into fx. This is equals to x cube minus 6x square plus 9, right?
Yes, ma'am.
Yeah. So, okay. So what can we factorize this? Can we factorize this? How? This will be equals to.
Yes, ma'am.
Yeah. How can we factorize this?
Minus 3x. No, ma'am.
What? Okay. So we can maybe write that minus 3x square plus.
बट मैम फिर ये 9x 4 हो जाएगा 9x की पावर 4.
Okay, wait, we can factorize it, but we have to find the factor.
Ma'am, I'm
Okay.
having a doubt. May I ask?
Yeah, sure.
Ma'am, in the class, sir has said every multiplication of a polynomial gives a polynomial, but every division may not give a division. Division is not a polynomial. He has said, could you just
Yes.
justify that?
Yeah, because if we, that's what I said, na? If we have the remainder as non-zero, then this is not the polynomial, right? You can see in this expression, in this example, when we are taking p as x square plus 2x plus 2 and q as x plus 1, then if we just simply do p by q, then we were getting this, right?
Yes, ma'am.
X plus 1 plus 1 by q. So this is not a polynomial, right? This is not a, this is not a polynomial because p is not divisible by q. But if p were divisible by q, then it will be a polynomial, okay?
Okay, ma'am. Thank you.
Yeah.
Okay, ma'am. Yeah, understood.
So in this example also, if this is given in the question that it will divide, it will be a polynomial after dividing it with this polynomial, then you have to factorize it. You maybe you will factorize it, then you can after factorizing, after all the term taking as common and after cancelling it, you will get something in simpler form, which if f is a polynomial, then we can find the value of f from the calculations. Okay, am I clear with the concept? I don't know what the question was. If this was the question, then we can do some factorization. We can cut some terms. So because I don't know what the question was, I am not trying it with. So whoever having doubt in this question, you can try it with the concept, which I just said. Okay.
Yes, ma'am. I can please continue next
Yeah.
topic.
Yeah. So these were all the algebraic operations of polynomials. We can now move to the graph. Yes.
Madam, there is one clarification required.
Can you be little louder?
Am I audible now?
Yeah.
So if you have two polynomials, okay, if the degree of a certain polynomial is less than the other one, the divisible is not possible. So what is that? Which is lesser than which?
Okay. So if we want to calculate p by q, then if degree of p is less than degree of q, then the division is not possible. If you have something degree 2 equation here, and suppose some degree 3 equation here, then we cannot get a polynomial after applying the division, right?
If the denominator is high, then the division is not possible.
Yeah, yes.
Yes, ma'am. Okay.
Yes. So if we want to do the division, then degree of p must be greater than degree of q. Otherwise, we cannot do the division. Okay. So Samuel, do you want to ask something?
No, madam. Apart from that, I have just one final question that is not related to week 4. It is related with the.
I cannot. I'm not able to hear you. Okay.
Ma'am.
Yeah. Yes.
Ma'am, one more question. I send it to chat box to you.
Okay, I will solve the questions, but let us first cover all the concepts. Okay, so there is
Okay.
one concept which is really important from the all the concept of week 4 is the how to plot the graph if you have given some polynomial, and the second question, if you have some graph, then how can we calculate the polynomial or degree of the polynomial? Okay, so this is
Okay, ma'am.
yeah. If we have graph of a polynomial, like from graph we can uh, compute the polynomial, and if we have the polynomial, then from this we can compute the graph. Okay, so rules, if we have some factor in this polynomial with some odd terms, then we can get, suppose this is the a and x minus a is the factor with some odd exponent, then we will get this type of odd other than like greater than 1. Okay, then we will get this type of picture. And second, if we have some even power, then at this point we will get this type of picture. And if we have a linear power, then it will just cross the point like that. Okay, so these are the basic rules that we have. Now we will draw the whole graph of a polynomial if we have the uh, equation. Okay, so suppose we have a equation px equals to x minus 1, x minus 2 whole square, x plus 3. Okay, so x plus 3, suppose cube. So how can we draw the graph? The first thing, while drawing the graph of a polynomial, we have to check the end behavior. So do you know how to check the end behavior and what do we mean by end behavior?
No, ma'am.
No, ma'am.
Highest degree of this.
Okay, so it depends on the highest degree. So if we have this polynomial, what is the highest degree here?
3.
3, ma'am.
3. 6
Uh,
odd power.
6.
Yeah, right.
Yeah, 6. Correct.
The highest
Yeah.
degree is 6. Because we have to multiply all the terms, then we can get the highest degree, right? So from here we will get 3, from here we will get 2, and then 1. So all over the highest degree 6, right? So now we can check the end behavior. So when x tending to infinity, that means if we just move along this axis in this direction, then what can we say about px? Px will be tending to infinity, right? Because from this term we will get a positive infinity. X tending to infinity means x plus 3 tending to infinity, and x plus 3 cube will be again tending to infinity, right? So from this term we will get a positive infinity. From this term we will get a positive infinity. Again from this term we will get a positive infinity, right? So if we just multiply all the infinities, then we will get again a infinity, right? So from here we can conclude that if x tending to infinity, then px will be again tending to infinity. Okay. And what if we tend x to minus infinity? That means if we move along this direction, minus infinity, then what will be the behavior of px? Anyone can unmute yourself?
Infinity.
Plus
Yeah.
infinity.
Why plus infinity?
Minus infinity, like minus, then again minus. So
If
Okay, so from this factor we will get a minus. From here we will get plus, and from this we will get a minus. So if we multiply that, we will get a positive infinity. Also we can check because the maximum degree is 6 here, which is a even number, right? So
Yes,
we
ma'am.
will get a positive. If the maximum degree is even with a positive coefficient, then we will get a positive behavior, right? That means we can say the end will be something like that. right? When x will be tending to infinity, the function will be tending to infinity. This is the positive side for the function. So in both the cases, the function will be tending to infinity. Now we have the x-intercept, that means the roots -3 with odd exponent, 2 with even exponent, and 1 with linear exponent, right? So this is our -3. This is 2. This is 1. Okay. So if the exponent is odd, then we know the graph will be like that in this place, right? Right?
Yes,
And
ma'am.
then,
Yes.
yeah, at the point 1, the graph will cut the axis. That means in this way. And when at the point 2, it will be something like that, right? Then it will get like that. So is the graph plotting clear? In this example, at least?
Yes, ma'am, but I have a doubt, ma'am.
Yeah.
If x stands to minus infinity, px stands to infinity. Can you explain that, ma'am? Px stands to infinity, how it will, like, it is a
Okay, so
positive
here,
infinity.
yeah. So here highest degree is 6, right? Which is even. And the coefficient of the highest degree is also positive, right?
Yes, ma'am.
So we are multiplying a positive infinity with positive number. So this is a positive infinity. This is one way. And the second way is we have 3 factors, right? So in the first factor, we are getting minus infinity, because x is tending to minus infinity, so x minus 1 will be tending to minus infinity, right? So from the
Yes.
first factor, we are getting minus infinity. The second factor, we have a square, right? So it will make the minus infinity as positive infinity because of the square, right?
Okay, ma'am.
Minus infinity square, that means positive infinity. And then in the third factor, again we have x plus 3 power cube. Okay, so cube
Negative
means
infinity.
negative infinity. Now if we just multiply all the term, then we will get a positive infinity. Okay,
Okay.
it's fine.
Thank you, ma'am. Okay.
So that is
Ma'am,
how
how,
if
ma'am,
we,
ma'am, how we are putting this minus to infinity
okay,
in the first
so
step?
means what are you saying?
How you are getting that where we have to put minus infinity, infinity, all those things?
I mean, you have to check instead of x, if you put minus infinity or infinity, how will be the behavior of the polynomial? Okay. So instead of x, you have to put infinity and or minus infinity. Then you can check the end behavior. And this is the y-axis. So if you are getting positive infinity, then the direction of the ending of the curve will be in the upward direction. And if you are getting something negative infinity, then it will be in the downward direction. Okay.
Ma'am,
Okay.
it comes back on the power, right? It is an even power, positive infinity, and it will, if it will be an odd power, it will be negative infinity. Like
Can you
this.
repeat? Can you repeat? I think there is some network issue. I cannot hear. Can you repeat?
That it all depends upon the power of the polynomial. If it is even, then it will be plus infinity, and
No,
if it
not
odd
necessarily.
power, then it will be negative infinity.
If the coefficient is positive and the power highest power is even,
Yeah. Mhm.
yeah, then we will get
Okay.
positive
It all
infinity.
depends on the
And if
coefficient.
the highest power is even and the coefficient is negative, here the coefficient of highest power is 1, right? Which is positive.
Positive.
Yeah, if we have something negative coefficient, then we will get minus infinity again. You just have to do the simple arithmetic calculation, positive, positive, negative things.
Yes.
Yeah, and nothing more than that.
Understood.
Yeah. So is the graph clear? So these are two steps. If you want to draw the graph, you have to check the end behavior. Second, you have to check the x-intercept and their exponent. And third, you have to check the y-intercept. So here, what is the y-intercept? I mean, this is the y-intercept, right? This point. So can anyone say what will be the coordinate of this point?
Y-intercept you're asking?
Yeah.
It
So we
is
will put
minus 108.
What? Minus
108.
108. Okay,
Yeah.
so we will just put x equals to 0 in the equation, right? So it will basically minus 1 into 4 into 3 cube, right? So whatever the value, this is the y-intercept, right? So if we want to
Yes.
calculate the graph of any given polynomial, so we basically have to first check the n behavior, then we have to check the x-intercept, and then we have to check the y-intercepts, okay? So these are 3 rules. So let us do another example. Suppose we have px equals to minus okay. So yeah, now you can assist me. If we take extending to infinity, what will be the behavior of px? Px will be tending to
Infinity.
minus infinity, right? And if we take extending to infinity, then what is px?
Infinity.
Still infinity.
Right.
Sorry, minus infinity.
Minus infinite. Infinite.
Then infinite, right? Because
Yeah.
here we have a minus. From here we will get a plus infinity. From here we will get a minus infinity. Okay, so minus minus will be positive. So we will get a positive infinity. Okay, so this is one way. And the another way is, what is the highest degree here?
7.
7. So which is odd, right? And what is the coefficient of highest degree?
1.
Minus.
Minus 1, right?
Minus 1. Yeah.
So this is an odd term and this is a negative term. That means we are getting minus infinity from the term, and then we are multiplying it with minus 1. So we will get a positive infinity, right? Is it clear now?
Yes, ma'am.
Like,
Ma'am,
how do you find that coefficient of highest degree?
Yeah.
So how to decide coefficient of highest degree?
This is the highest, this will give the highest degree, na? X, from here we will find x power 5, and from here we will find x square, right?
Yes, ma'am.
Yeah.
So from here we can compute the coefficient. If we just break the equation, okay? But suppose if we had a
Coefficient of
minus x plus 3 here, okay? Then we will get a negative. I mean,
Then the whole
here from
equation will
here.
become positive.
No, let us check. From here, the highest degree will be x square, right? And
Yes,
from here, we will get
Yes, ma'am.
minus x to the power 5, right? Now,
Yes.
if we calculate the highest degree, we will get minus x power 7,
power
right? And
7.
here, there is one minus outside. If we just multiply it, then we will get x power 7, right? Then we
Yes.
will get minus infinity. It's fine now?
Yes, ma'am.
Yeah. That means if we get a positive coefficient with the highest degree term, then we can decide it. If it is even, then it is infinity. If it is odd, then it is minus infinity. And opposite for the negative coefficient. Now is it clear? Or else if you have doubt, you can ask.
highest
Yeah, ma'am.
degree coefficient positive है ना मैम?
Here the coefficient is negative because of this minus. Because here the equation was this.
But our
X
original
minus 3.
equation was x minus 3 now.
Yeah.
Then in that case, so positive.
Yeah, in that case, we have a negative coefficient. Because of this minus, here we have a minus, no? So from here, we will get x square. From here, we will get x power 5. So if we multiply, we will get x power 7 with this minus. Then we will get minus x power 7. Okay? So odd and with multiplication with minus of something. So we will get something infinity. Is it fine?
That -1 is coefficient of x.
X power 7, the highest degree of the term. I mean, the polynomial.
Next table, -1, coefficient of x is -1.
X power 7. X power 7.
Okay,
This is the
yes, ma'am.
coefficient of highest degree term.
Okay.
Okay.
Okay, fine.
Okay. So again, and what are the x-intercept? The first x-intercept is 2 with the even degree, and the second intercept is 3, right? Sorry, -1 and 3, right? With the odd degree, right? So how will be the graph? If x tending to infinity, then px is tending to -infinity. That means if we move in this direction, x tending to infinity, we will get the graph in the downward direction, right? Tending to -infinity. Is it clear? And
Yes,
if
ma'am.
x tending to -infinity, then if we move towards this direction, the graph will be positive infinity. That means in the positive direction. Clear? Now, we have the intercept as -1 and 3. Suppose this is our -1, this is our 3. Okay. So the degree of the factor x plus 1 is 2. That means it will just touch the graph at the point, something like that. Okay. And then it will be something like that. Okay. Clear? And this is the y-intercept. What is the point? We can calculate if we just put 0 instead of y in the equation. Okay.
Explain the graph now once. Oh,
Yes. Yes.
explain the graph now once.
I am explaining the graph, na?
One can explain.
Is someone saying something?
Can you please repeat the graph?
Yeah, I muted all. Now, if you have doubt, you can unmute yourself and ask. Yeah.
Can you explain the graph once again, ma'am?
Okay, okay. So let us draw the graph again. So our first point is we will check the end behavior. These are the end behavior, okay? When x is tending to infinity, px is tending to -infinity. That means if we move along this direction, x is tending to infinity, px will be tending to -infinity, like in this direction. Okay, so this is the movement of px. This is going to -infinity in the downward direction. Okay, and if px x is going to -infinity, then px will be tending to positive infinity. This is a movement of px. Okay. This is the end behavior. Is it clear?
Yes.
Yeah. Now we will check. Yeah. Now we will check the x-intercept. So what is our graph? The equation is -x plus 1 square x minus 3 to the power 5, right? So what are the x-intercept?
-1 and 3.
-1 and 3, right? And
Yep.
what is the degree of the factor? -1 is 2. That means something even, right?
Yes.
So if we have something even, that we know the graph then just will touch the point like that, right?
Yes, ma'am.
Yeah. And for the intercept 3, what is the degree? This is odd, right? Suppose this is odd, then we know that the graph will be like that, right?
How
Yes,
much
ma'am.
this graph will bounce? How many points? If it is even multiplicity of 2, how many points it will get bounce?
But means what are you trying to say? I am not
X
getting.
plus 1, the
Yeah.
multiplicity is 2. So it
Yeah.
is bouncing from
Yeah.
negative. I mean, yeah.
This.
So how much unit it can be?
Okay.
Possibility.
So okay. So you want to measure the quantity. So suppose this is bending that much. Okay. That means this will cut the y-axis at that point. Okay. So this
Yeah,
is the
that is
y.
fine. If it is,
Yeah. Then
if it
it
is
will
in
be
between
connect.
intervals are there. Let's say, for example, not in this graph. -1 is there, -2 is there, something.
Okay.
So if I'm touching -2 to -1, how much it will be?
-2 to -1.
In between this. So y-intercept, it is you are saying okay, fine.
Yeah.
It directly go to and touch, and next it will go to the
Yeah.
right side. But whereas here, -2 to -1, if there is two intervals, for example,
Yeah.
-2,
From
I'm
here to
having
here. In this graph, or you are saying like
yeah, correct.
in this interval, right? So in this interval, the movement will be like that. Okay. Will be like that. But how much it will bend, we can decide it with the, like if we put the point over the graph, then we will get the points, right? So
If like x -2 also is my one of my zeros here.
okay, so with we have x plus 2 this factor then. Okay.
Yes,
So
correct.
what is the
So
exponent?
power 2.
Power 2.
Ah,
Okay. Then we will get another this type of thing here, right?
correct.
Then let
That's
us
what.
read it.
How much units it can be bounced?
Okay, wait. Then see, if you have this, then we will get this type of thing, right? Okay.
Yes.
And you want to check how much bound it will be, right? Means this curve, right? So
Yes.
for that, at this point, you need to check the functional value. Okay. In this interval, you need to check the functional value, and the amount of the bounds will be basically depending on the it will be like it will depend on the functional value of the graph. Okay.
Got it. Thank you.
Yeah. So then we will connect this and we will get this blue graph. Okay. Now is it clear?
Yeah, clear. Thank you.
Yeah. So the white one is with this two factor, and if we add this factor, then we will get the blue one with the in the negative side, and the white same as the white one in the positive side. Okay. And the y-intercept can determine at which point the graph will cut the y line. Yes. Okay, so any other doubt with the, if we have some equation, then how can we draw the graph? Any other doubt?
How we get the two that even
What?
-1 is that even, no?
Yeah,
How we
this
get
one.
the two? You know, intersection -1 is to 3. The 3 is odd, and -2 intersection, and didn't get that one.
Can you repeat it? I mean, I'm not getting your point maybe.
I'm asking for x-intercept -1, which is even.
Okay, so x-intercept means basically you have to equate px equals to 0. I mean, you have to calculate the roots. So here you have factors, and if you equate it with 0, then all the factor will be 0 individually. From that, we can find the roots or the x-intercepts.
Okay, ma'am, where x is equal to, we have to put instead of x -1, right?
X -1. Why? Here the x-intercept is -1, no? So x minus of -1. That is why it is x positive 1.
Okay.
Is it your doubt?
No, my doubt is that 2, which is even. How we get that?
This. The 2 is even.
No, ma'am, that's square. No, x-intercept -1.
This one.
Below -1 is there is arrow, no? 2.
Yeah, this one. This 2.
No, below. X-intercept -1, comma 3.
Okay.
But
This one.
he's talking about the power of
Power of
Okay.
minus.
Yeah, so if we have this factor, no? From this factor, we are getting the x-intercept -1, and we are taking the power of this factor. from which we are getting the x-intercept. So here the power is 2, which is even. That was the like concept. Is it
Ma'am,
yes?
yes, ma'am. That's good. Thank you, ma'am.
Yeah, ma'am, I'm
The
aware with
multiplicity.
in point.
Yeah, multiplicity. Yeah, you're correct. Yes. What was you saying?
Yeah, ma'am, I am aware with end point, but I'm confused how to put in graph. Means I understand, ma'am, what I'm.
So these are the 3 steps. That is what we are doing. No, we have to calculate the n behavior, then the x-intercept, then the y-intercept. That's all.
Madam,
So
could you please explain the n behavior again? So,
yeah, okay.
thank you.
Okay, so let us do it with one more example. Okay, so maybe one of you can suggest one example. I did 2 from my mind. You can suggest one polynomial so that I can draw the graph.
Ma'am, x minus 1,
X minus 1,
x minus 3 whole square,
x minus 3 whole square,
and then x minus 5 cube.
x minus 5 cube. Okay, so yeah, this is the polynomial, right?
Yes, ma'am.
Okay. So we have 3 steps. Step 1 is we will check the n behavior. Step 2 is x-intercept. Okay. And step 3 is y-intercept. Okay. So what will be the n behavior? You will answer it. I'm not going to answer. So yeah.
It will start from
Positive.
positive, ma'am. Positive infinity.
It's positive for plus infinity.
And if we take x tending to negative,
Still positive.
For PS, it's
Positive infinity.
it will still a positive infinity, right? Because the highest power is 6, which is positive, and the coefficient is 1, right? Which is again positive.
Positive.
Yeah. So anyone having doubt with the n behavior in this example?
In this way, if you are explaining, then it will be confusing only. Better you should have explain how the 4n behaviors with the even and odd coefficient with multiplicities. So then only people would be understanding better, because this will be confusing again and again. There are totally 4 graphs only.
For example, you can make a table for like if
Correct.
coefficient is
That's what
negative
people
or
are
positive.
expecting.
So yeah, you know how to calculate the highest degree and coefficient, right? So there is no issue with this, right?
So,
Anyone?
madam, now the n figure you defined, no? This one for the highest, what is the all multiplication, what is the highest degree? For that only we are framing the n figure, right?
Yeah, yes. So
Okay.
first, we need to ensure that all of you know to calculate the highest degree and its coefficient. So I think all of you know to calculate the highest degree is easy because you just have to add all the degrees, and coefficient means you will see the coefficient of all the x present here. Then with the power, we will multiply it. Okay?
Okay.
Yeah.
Then after see when we plotting everything, so individual for example x minus 1, the if we consider it as a power 1, so maybe
Yes.
it will cross through the x-axis. So that
Yeah.
if you are seeing individually also the endpoint will satisfy, right?
Yes. Yeah. So all the factor it will satisfy at that point, and if we multiply them together, then we will get the polynomial. Okay. So if this is the highest degree, so if the highest degree is odd, okay, and the coefficient of highest degree, if this is positive, then we will get a negative infinity, right? If we have x equals to negative infinity here, right?
Yes, ma'am.
Yeah. So this is for negative infinity. And if we have odd, the highest degree, and negative, the power, the coefficient, then we will get a positive infinity here, right?
Yes, ma'am. Yes.
So we have these two possibilities only. If we have minus infinity, the highest degree, if it is positive, if it is odd, then the coefficient may be positive or may be negative, right? So if it is positive, then it will be minus infinity, and if it is negative, then it will be positive infinity. And if we take minus infinity with even. Okay. Then again, we have two different cases. The coefficient may be positive or may be negative, right? Okay. So if we have even, like minus infinity power something even, then we will get positive infinity, right? And if the coefficient is positive, then we will get a positive infinity. Similarly, for this, we will get the negative infinity. Okay. Up to now, is it clear? The chart?
Yes, ma'am.
Yes, ma'am.
Okay. So same thing we can now do for infinity. If we have infinity, then we have two different cases. First case, the degree of the highest, the highest degree term, it can be something odd or it can be something even, right? So these are the two possibilities. Okay. Again, if we have odd, the coefficient can be positive or it can be negative. Okay. And for even also, the coefficient can be positive and the coefficient can be negative also. Fine. So if we have positive infinity, doesn't matter if the power is odd or even, it will be again positive. Okay. When we are applying the power. So if we have positive infinity, here we have positive infinity, here we have positive infinity. Now if we multiply positive infinity with something positive, then we will get a positive infinity. Here we will get a negative infinity. Here we will get a positive infinity, and here we will get a negative. Okay, so these are the whole chart. All the cases are there. This is the thing: positive, positive, negative, negative, negative. Positive, 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 negative, negative, positive. That childhood things. So yeah, is it clear now?
Ma'am, one doubt, ma'am.
Yes.
In a positive infinity, x equals to positive infinity, highest degree is odd, right, ma'am? First case positive, coefficient of highest degree is positive, ma'am.
Yeah. So we
Not
have
in first case, ma'am. Third case, I'm asking positive infinity. Highest degree is odd. In odd,
Okay.
first case is positive, then odd into positive is negative, right, ma'am?
Why?
Negative infinity.
No, here we have positive infinity. Then we are multiplying it with something positive. So we will get a positive infinity.
Okay, ma'am.
For example, we have 2 into infinity. This is infinity, right?
Yes,
Minus 2 into infinity is minus infinity, right? That is what I am trying to say.
Okay. Thank you.
Yeah. So is the chart clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So now we can move further. So these are the end behavior. Now is it clear? I mean the end behavior.
Yes, ma'am, it is.
Yes, ma'am. It is clear.
Okay. So what are the x-intercepts? Anyone?
1, 3,
Plus
5.
1, plus 3, and
1,
plus 5.
3 and 5. 1 with linear, 2 with even, and 3 with odd term, odd degree, right?
Yes, ma'am.
Yeah. Now we will draw the graph, okay? So let us first check the end behavior. So in both the cases, Px is tending to infinity. That means the ending will be in the positive side of the y-axis, right? This is
Yes,
not
ma'am.
clear? Yeah.
Ma'am.
Yeah. Then our first point is 1, 5, and 3. So we will point them out. This is 1, 3. This is 5. Okay. Now with 1 we have linear degree. That means something like that. It will cut just like that, right? From 3 we have the degree is something even. That means at the point 3 it will touch like this. Okay. So we can now join the curve. It will be like this. Okay. And at the point 5 the degree is 3. That means something odd. So it will be like this, right? Then we can connect it with the end. Here also we will connect it with the end. And this point will be determined by the y-intercept. Now is it clear?
Yes, ma'am, very much.
Okay. So
Yes, ma'am, it is clear now.
okay. So I guess it's clear to all of you. So now we have graph. So we can now talk about the turning points. So turning point means if we have one point, we can say it is a turning point if before the point, suppose if the graph were in the something in increasing, and after the point the graph is decreasing. This is one case. We can say the point as a turning point, and this is another case. Before the graph, the graph was decreasing, and after the point the graph is increasing. So this is another type of turning point. That means the nature of the graph will be different before and after the point. Okay, that point we will say as turning point. Okay, so you know the definition. Now you have to tell me how many turning points are there in this graph.
As there will be even power polynomials in there.
3 turning points are there, ma'am.
3.
So can we count them? This is 1, this is 2, and this is 3, right?
Yes, ma'am.
1, 2, and 3.
Only
So
3.
yes.
Only 3.
I cannot hear you. Sorry. So these are the turning point here. Let us come with this graph. In this graph, how many turning points are there?
1, ma'am.
2.
2, ma'am.
2.
2 turning points are there. That means this one and this one, right? This is one turning point and this is another turning point, right? 1, 2. Okay. So this is the turning point thing. So suppose we
Ma'am,
have
point means
negative
it's
x-axis. Ma'am, in
Yes.
previous graph there is negative x-axis another turning point, right, ma'am? In previous graph, it's not, ma'am. It's another graph, ma'am.
In this graph,
It's not, ma'am. Another graph, ma'am. If you shown last time.
this
Last
one?
graph, ma'am.
Yeah, this is the last graph. This is the last graph.
Okay, ma'am.
Yeah.
He's
So
asking
here the
previous one.
number of turning point is 3. Okay. Yeah, we will consider more graphs. Don't worry. So suppose we have this. Okay, this is the graph. So how many turning points are there?
6, ma'am.
6, ma'am.
So we can count. This is 1 because here it is decreasing, then it is increasing. This is another. Okay, so this is the third one. This is the fourth one. This is the fifth one. This is the sixth one. Okay, so total number of turning points is 6. So if we have a graph, then we can calculate the total number of turning points just after seeing the graph. Okay. So yeah, is it fine with everyone?
yes, ma'am.
Okay.
Yes, ma'am.
Okay.
I think x-intercept will not consider as turning point.
No, intercept with
That's
mean.
the activity
If we have some odd degree,
where
then we cannot consider. But if we have even degree, then we can consider. Then it will be a turning point. Okay?
okay.
Yeah. So suppose if we have this graph, let us consider this graph. So what will be the least degree of the equation of the polynomial?
7.
How can we calculate the least degree? Yes.
5.
5.
7.
7. So any another answer? Any other? 5, 7 and so let us
How
count.
to
Minimum 7.
calculate it?
Yeah, I will cover it. Okay. So we need to calculate a degree. So we will calculate the x-intercept. Okay. So let us first check what are the x-intercept. So this is one x-intercept with degree. With degree even, right?
Even degree.
Yeah. So this is second x-intercept with
Even degree.
yeah. And this is another
Odd. This
linear.
one is odd.
Odd or it is specifically one, right? Because
Yes, ma'am.
it
Straight
has just
line.
cut the graph at that point. This is another. So what is the degree here?
Cube or more than
And
one.
something odd. Yeah, something odd that is greater than one, right? And this is the last x-intercept with again something odd greater than one, right? So what is the least possible even number? Non-zero, it's 2, right? Similarly, here we will get 2. From here we will get 3. From here we will get 3, right? So if we just add them, we will get 2 plus 2 plus 1 plus 3 plus 3. So it will be how? 11, right? Okay. So 11 is the least degree of the graph. Okay. Is it fine?
Depends upon the turning point, right?
Okay.
Yeah. We
The
will
x-intercept.
consider.
The
How many turning
x-intercept, I
points?
guess.
We will check all the x-intercept. Okay, not the turning point. The x-intercept may not be the turning point. Also, it may be the turning point. Okay. But if we need to check the degree, we will consider all the x-intercept and the behavior of the graph near the x-intercept. Okay. So, and we know for which degree the graph is behave like the graph will behave in which way, right?
What sort of questions can come like this, madam? This.
Sorry, ma'am. How
Hello.
are you putting the 3 plus 3, the last two number you put in, right? So the 2 plus 2 plus 1 is fine. How are you putting this last two, 3 plus 3? Yeah.
Okay, so check here. Wait. So here the graph is behaving like that. This is one and this is another, right? So
Yes.
this one and this one are two different x-intercept.
Correct,
And
ma'am.
we know that at that point the graph is behaving like this, or like
Yeah.
that. That
Okay.
means we have a odd degree.
Odd degree, correct,
the
correct.
factor, right? So
Correct.
if we have odd which is greater than 1, that means what is the minimum possibility?
Okay,
Is it
okay.
3, right?
Yeah, got it, ma'am. Thank you.
That is what we are taking 3.
We are
Okay, so
taking the minimum degree.
Yeah, we are taking the minimum degree because we are calculating the minimum degree of the graph, right?
Yes, ma'am.
So yeah.
The third one, it's almost linear, right? Third one.
Yeah, this is linear.
Okay.
So it is 1. Okay. Because it has just cut the x-axis, right?
Okay.
There is no like turning at that point. Okay.
Yes. Thank you.
Okay, so let us work with another.
The minimum degree is 3 now.
I'm saying about the total degree, na? Like the
Okay.
highest degree. Highest degree is the degree of the polynomial, na? If you have a polynomial, and what is the degree of the polynomial? The degree of the highest degree term, exponent of the highest degree term, right? So the highest degree will be this.
11.
Yeah, 11. So yeah, let us work with another example. Suppose we have this. Okay. Okay. What is the number of minimum degree here? What is the number of minimum degree? No fear. You can unmute yourself and tell.
14.
14.
14. So any other answer other than 14? Don't worry, we will calculate together. Okay.
12.
14, 12. You have to follow the similar process all the time. So what is our first step? We will check the x-intercept, right? Okay. So how many x-intercept are there? Number of x-intercept is?
8 x-intercepts,
8.
ma'am.
Okay. So
8.
1, 2, 3, 4, 5, 6, 7, 8. So total 8 intercepts are there. Okay. From this intercept, we will get a
Odd.
3.
odd, right? Greater than 1. That means
3.
we will consider the minimum 3. Okay,
Ma'am,
let us
odd
consider the
less
minimum.
than 1, right, ma'am? It is because the left side of the graph.
No. Left side, because the number, I mean the x-intercept is negative, not the degree. Degree is always positive, no?
Okay, ma'am.
Degree, I mean exponent belongs to natural number. It is always positive, okay? This is in the negative side because suppose we have this factor to the power 3, okay? So because this is negative, that means here we have -1 intercept. That is why it is in the negative side, okay?
Okay.
But the exponent will be always positive.
Ma'am, I would like to correct myself. It's 14, not 12.
Okay. So let us cut the 12. So all of you
Yes,
agreed with
ma'am, it's
14.
14. Yeah.
Okay, so let us conclude. So from this one, we will get a linear degree, right? Similarly for this one, and this one, we will get a linear. From this point, we will get a 2. From this, we will get a 2. And from here, we will get a 3, right? So what will be the highest? 3 plus 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So this is the correct one. So the number, like the minimum possible degree is 40. So yeah, is it clear?
Yes,
All of
ma'am.
you?
Yes, ma'am. Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. So suppose we have this polynomial. This is -2 and this is 5. Okay. And suppose this is 1. Okay, the y-intercept. Now you have to tell me what is the graph, I mean, what is the equation of the polynomial? Here we have a graph. From this graph, we have to determine the equation of the polynomial. First, tell me what is the number of turning point?
2, ma'am.
2.
Yeah,
2.
right.
2.
Yes. Very good. Correct. So the number of turning point is 2. So, okay. So what will be the equation of the graph?
X plus 2 whole square into x minus
X minus
5
5 whole cube.
whole cube.
Whole cube.
Coefficient minus.
Yeah, minus coefficient. As we see, the end behavior according to.
Here will be some coefficient which I don't know, right? So how to calculate the coefficient? Simply put x equals to 0. Then we will get p of 0 equals to a into 4 into minus 125, right?
Yes, ma'am.
So we know the y-intercept is 1, right? That means P of 0 is 1, right? So from here, can we calculate the value of A, which is minus 4 into 1. Okay, this is the value of A. Is it fine?
Ma'am, can you please explain how we found A?
Okay, so here will be some coefficient. So I don't know what is the coefficient, but I have to calculate the coefficient, right?
Yes,
So in this graph, we have given that the y-intercept is 1. And y-intercept means P of 0, right?
Yes, ma'am.
Means we will put just x-intercept instead of 0. So P of 0 equals to 1 we have, okay? And A is unknown here. So how can we calculate the value of n? So we will simply calculate P of 0, which is this one, right? Here, if it is 0, then we will get 2 square, that means 4. And here, if x equals to 0, then we will get minus 5 cube, that means minus 125, right?
Madam,
Yes,
this
ma'am.
x minus 5 the whole cube, it may possible of 5 7 also, right? Power.
Yeah, but here we are taking the least degree, okay? We
Okay.
will always work with the least possible degree.
Okay. Okay.
Yeah,
How come 155 you written?
yeah.
125, no?
125 it should be.
Yeah, it is
Therefore,
125.
A equals to minus 1 by 500.
Yes. So the
Okay, ma'am.
polynomial then will be x equals to minus 1 by 4 into 125 into x plus 2 square into x minus 5 cube, right?
Yes, correct.
Now we can cross check. We have a polynomial. Now suppose we want to draw the graph of this polynomial. How will be the graph? What will be the end behavior? You will tell me. I will not tell this time. If x tending to infinity,
Infinity.
What
Minus infinity. Minus
Minus.
infinity.
Minus.
yeah, yeah. Very good, very good. So if extending to minus infinity,
Infinity.
Infinity.
Plus infinity.
okay. And what are the x-intercept?
Minus 2 and
Minus
plus
2
5.
and 5.
And 5. Minus 2 with even and 5 with
Odd power.
So how will be the graph? It will always the positive, so n will be in the positive side, okay? So this is the minus 2 even, that means it will bounce here, okay? And at the 0.5, it will be like that.
No, ma'am, it will go down from the
It will go
positive
down.
side.
Okay, see, then this should be, oh, sorry. This is minus infinity, my fault. Okay, so this graph will be here at the, when x is tending to infinity, right? Because of this minus infinity. I missed it, okay?
Yes, ma'am.
Okay, yeah.
Small
Okay,
doubt.
so at the 0.5, it will be like that. So now we can now just connect them. So this will be the equation of the, this will be the graph, something like that. It's not perfect, obviously, but it will be something like that, right?
Yeah, one doubt, ma'am. Sorry to interrupt. You were mentioning about x minus 5 degree as 3, right? Which is the minimum, right? Even if I say x minus 5 to the power of 1 is also odd, right? So why we are taking 3 here instead of
We are taking something odd which is greater than 1, because if we have linear, then we know the graph will just pass, like it will be the straight, it like a straight line. Okay.
okay.
We have some different type of figure for particularly the linear exponent. So we will exclude 1, okay? We will start from 3 here.
Okay.
Now we can match the graph. Are they same? Yeah, they are same, right?
Yes, ma'am.
Yeah. There seems to be different because of my bad drawing, but the movement is basically same, right? The Okay?
Yeah, correct.
Yeah. Okay. So let us try with another example. I will draw a graph. You have to tell me the equation. Okay?
There is one more question.
Yeah, sure.
So, when the multiplicity even or odd, so if it is a multiplicity even is getting bigger and bigger,
Yeah.
my intercept will be flatter more and more.
Yeah.
Correct?
Yes.
Why?
Yeah. So because the
Why?
oh shit. Wait. Are you able to see the screen?
No,
No, no.
ma'am. Blank.
No,
screen.
ma'am.
Wait, I just got disconnected. Let me rejoin. Oh. Please, wait for some time. I'm getting you back. Okay.
Okay, ma'am.
Okay, ma'am, no problem.
Hello. Yeah. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes,
But
ma'am.
not visible,
Yeah.
ma'am.
Yeah, I need some time to share my screen. Actually, the man who is host, he had to make me co-host again because I got disconnected from the iPad. Okay, so please wait for some time. Mm. Up to then, we can discuss it normally. So, what was the question?
You have given me a graph, ma'am, to find
Yeah,
out the polynomial equation.
yeah. Okay, so you cannot able to see the graph right now. So someone has asked
Yeah.
some
I asked that question.
question. Yeah. So the more the odd degrees, it will get more flatter at the point. So
Yes.
it can be answered from some intuitions like so if the degree is more, that means the multiplicity of the x intercept is more, right?
The multiplicity is getting bigger and bigger. I mean,
Yeah,
either it
multiplicity
can
is
be
getting
order.
bigger. Like if we have something power bigger than the like previous one, in that case we will get the intercept x-intercept with a greater multiplicity, right? So if the x-intercept has a greater multiplicity, then it's the common intuitions that the graph will touch the x at that point for more time. Like it's just something from intuition, you can say.
There is no correct reason, only just intuition.
right now I don't have exact proper reasoning. I can say you from my intuition, but what I think, if we just check from like using the point, I mean the movement of the graph, that means yeah, now my screen is visible, I guess, right?
Yes, ma'am.
Yeah. So
Yes,
yeah,
ma'am.
what I was saying, if we check the movement of the graph, that means if we take all the points from like in the close neighborhood of the point, so if we check the functional value, then we will get the curve like that. So this is purely mathematically, and the intuition is like that, because the multiplicity is higher, it will be more closer to the point at at a close neighborhood of the point.
Ma'am, I have a doubt, ma'am.
Hmm.
Regarding this graph, ma'am, the first x-intercept, do we consider it as a even power, ma'am?
Yes.
Yeah, downwards or upwards, we should consider even power, no?
Yeah, yeah.
Okay, thank you.
Okay.
And second
So
x-intercept is is passing through origin, right, ma'am? So what should we consider that, ma'am?
so if it is passing through the origin, that means we will have a factor x minus 0, similar kind of
So
thing.
yeah, okay.
So yeah, now you have to just suppose this is minus 5, this is 0, you know, and suppose this is 4. Now you have to tell me the equation.
X plus y whole square into x minus 4 whole cube, ma'am.
X plus 5 whole square into x into
X minus 4 whole cube.
okay. So everybody is agreed with it, or any doubt? There is no a here, right?
Yeah,
Because
yes.
we know the x-intercept and y-intercept. I mean, the y-intercept is 0 here. So if we put x equals to 0, we will get 0. So there will be no constant, right?
Okay.
If any constant is there, still doesn't matter. Okay.
Okay, ma'am.
Also, what can we say about the end behavior of the polynomial when extending to infinity?
Infinity.
V of x tends to infinity, ma'am.
And when minus infinity?
Infinity.
Infinity.
Okay. So again, we can draw the graph from the polynomial, which will be similar as
But
that.
ma'am, the graph is not correct if we.
Yeah. It is not correct. It's contradicting.
Okay, right. Yeah, that's the point I wanted to make. So in order to rectify the, the equation, what do we need to do? What should I add with the equation?
Minus.
Yeah, right. Perfect. So if we just simply add a minus with the equation, then we will get this type of thing. That means minus infinity, and here it will be minus infinity, right?
Why should we add minus to an equation, ma'am?
Because see the end behavior here. Okay, when x is tending to infinity, it is going towards minus infinity, right? From the polynomial also, we should get the same. If we don't add minus here, then the graph should be like that, okay?
Okay, ma'am.
Is it clear now? The dotted line without the minus sign, and the clear line with the minus sign, okay? Okay. So is it
Yes, ma'am.
clear? Yeah, is it clear now?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, so I think these are the concept in your week 4. Maybe there was no more concept left to cover. So if you have any doubt regarding these concepts, now you can ask.
Ma'am, these much of small topics are there in week 4, ma'am. That's it.
Yeah, what I think it's up to that only. It's only about polynomials and about the graph of polynomials, the turning points. If we have a polynomial equation, we can draw the graph and vice versa. So yeah.
Hello.
Okay.
Yes.
Thank you.
Hello.
Yes.
Madam, you are saying that x tends to infinity and the equation p of x tends to minus infinity. How are you arranging in that? When you are taking the equation x plus 5 and you are determining that, or how are you doing it?
Can you repeat? Can you repeat?
What I'm saying is, if x tends to infinity, you
Yes.
are mentioning as p of x tends to minus infinity.
Yes.
So how are you determining that? Like how do you come to a conclusion of that? Is it the equation that determines
Yeah.
that, or how?
Because this is, if the equation and the graph are same, I mean the graph is of the equation, so the end behavior should be same, right? So from this one, we can find that the end behavior are like that. Okay. So from the graph also we can check it. I mean, when x is going towards infinity, then the polynomial is going towards minus infinity because it is in the negative side, right? And similar for in this direction also. Is it the doubt or something
That is
else?
what I'm asking you. Like how are you, if there is some equation and if they have asked us to, conclude that what is p of x, what it
Yes.
tends to or something like that, how?
Yeah, you have to check the end behavior also in that case. I mean, you have this type of equation, right? So similar type of thing. I mean, you have to check the a here. So p of x equals to a and all the factor, okay? Plus 5 squared x minus 4 cube, okay?
Okay.
Now we can check the value of a. So p of 0 is 0 here. We know that, right?
Correct.
So, okay, we cannot check here directly by putting this. So, we can do it with the end behavior. Like,
No, we can easily assume the degree. It is just adding up the powers and assume the end behavior of the degree. But just to make sure that x is tending to infinity. But if we come to a conclusion saying that x tends to infinity, can
Yes.
we automatically say that p of x tends to minus infinity?
Can you repeat your point?
If there is a, for example, let us take this x minus 4. So x is equal to 4, correct?
Yeah.
So that is in positive side, isn't it?
Yes.
So
Yes.
can we say p of x tends to minus infinity? Is that the way we have to assume or how?
No, from here, how can we say that p of x tends to minus infinity?
That's
We
how.
cannot assume because if we want, see, the step is like if we have the graph. So right now we know the end behavior from the graph, right? So you have to check that whether the equation is also satisfying the same type of behavior or not. Okay, if the behavior is same, then nothing to do. But if it is opposite, then you have to multiply with the constant so that you can like the behavior will be same in that case. Like
So
to
depending
do it.
upon the logical thinking, we need to assume.
Yes, yes, yes.
Okay, now that is point number one. Point number two is how do you determine the coefficient?
Coefficient of what? I mean the
Coefficient
height.
of the, say if the graph is given, so if they
Yeah.
are asking us to find out the equation of the graph. So how, this x plus 5 or
Yeah,
the
for
square
that
of
you need to assume some like random coefficient like that. Here in this equation, I take a, right? This is something unknown. Now, if I know the y-intercept, from the y-intercept, now I can calculate the coefficient in this way. If we
okay, so
put
that is
equals to
the
zero,
only way to do it.
Yeah. You have to assume something random. Then after putting the value, you can calculate the value of the constant, and it will be the coefficient.
Okay, and one more final doubt on the mathematics part alone. So is it week 5 is more required compared to other weeks? Like you have already released the week 5 content, and it is almost correlating with the week 1. That is, the extension of week 1. So is it required for the examination point of view, or should we omit it?
No need. So in your in quiz 1, there is just up to week 4, and for quiz 1, you don't need to be worried about week 5.
So if we don't
There
submit
are
the
some
assignment also, no, then it's not going to be a problem. Graded assignment.
No, there is no connection with the week 5. Okay, so from in week 5, there are some more extra concept. There are some concept from week 1 maybe, but there are also so many extra concept. So you need not to be worried about week 5 right now. So after your quiz 1, you can start with this.
Okay. And this is going to be similar questions as per the concepts and the explanation that
Yeah.
is in the portal and the
Yes.
virtual
Yeah.
discussions.
And
Ma'am, I
for
have one doubt, ma'am,
Yes.
regarding the question. Ma'am, will you explain the end behavior of this problem, ma'am, last problem? For x tends to infinity, p of x tends to minus infinity, right, ma'am? This problem.
Yes.
For x tends to minus infinity, p of x tends to also minus infinity, right, ma'am?
Yes.
Yeah.
So here, similar way, you just need to calculate the highest degree and the coefficient. The coefficient is -1 and highest degree is 6, which is odd. Now you can match it with the chart, right? So we will find.
I shared a screenshot of chat in the chat. You can open it, you can it's easy to understand.
And I have basic doubt. Yeah, this regarding the same from the last problem. When you were talking, because I had too much, so I couldn't call you before. When you are talking about p of x is x plus y the whole square and this thing x minus 4 the whole cube. So could you please explain how the power is coming in terms of graph? Because I missed those discussions a lot.
So yeah, we can. Yeah. So these are the simple. If we have something odd, then the graph will look like that. If we something have even, then graph will look like that. And if we have something linear, then the graph will just pass the x-axis at that point. These are the thing you should keep in your mind. Then based on the thing, we can draw the whole graph of a given polynomial, or we can detect the equation.
I'm actually, my doubt is about the last graph where you are actually deriving the equation. So how did you say it's x plus 5 the whole square? Yeah.
Because we have this turning thing here, right? Like a parabola. So this is for something if we have the degree as even.
So that's
Here
it's -2 here.
What?
Is it -2 there?
No, the exponent is always positive. It should be a natural number. Exponents never negative. Exponent is always positive. So the degree is something which is positive even number. And we will always consider the less one. So here it is 2.
Excuse me, ma'am. For
Yeah.
any for the I any have graph, sorry, ma'am, for any graph that is passing through the origin, the one which you have, the a or like the coefficient, can we take it as 0, or only in this case it is like that, ma'am?
Coefficient means
I
like
mean the a which you are saying that it is 0, right, ma'am? Because y here is 0 because it is passing
A
through.
is not 0. A is not 0. A is -1 here.
Okay,
If
ma'am,
we
can you please scroll down, ma'am? The way you calculated a, can you just see that?
A is P of 0. P of 0 means the, like, A is not P of 0, sorry. From P of 0, we can calculate the value of A.
No, ma'am, not in this example, ma'am. This is, we have already y-axis, ma'am, but the last example that which passes through the origin, you said that x equal to 0. So if you substitute that here, right, ma'am, P of 0, that it will come as a 0 only, right, here.
Yeah. So in this case, because this is a special case, we have the y-intercept as 0. So we will find P of 0 equals to 0, right?
Yes, ma'am.
So we cannot like calculate the, if we take suppose A here, so from this equation we cannot calculate because A into 0 will be 0 again, no?
Yeah, so
So
that's what I'm saying. For any,
yeah.
the
So
any
that
graph
thing
that
is,
pass.
listen,
Sorry.
please listen,
Yeah.
listen. So yeah, in this case, we will find A into some 0 equals to 0, right?
Correct,
So
ma'am.
if we take A, like any value instead of A, it will satisfy the equation. Okay. So there are two possibilities. The A, it can be positive, it can be negative, right? So from this equation, we cannot determine the particularly if A is positive or negative. In this case, we need to check the end behavior to determine the sign of the constant A. Am I clear?
Not fully, ma'am. I'm sorry, so I couldn't be able to.
Okay, no, it's fine. You can ask out.
Actually, when you are saying about when it is passing through the origin, you were saying like we will, as you explained, we will be substituting 0. So we'll get the. I think the problem is whether there is a constant. Then it has the value 1. You're saying -1.
Yeah.
But when you said when it is especially passing through the origin, the A, you said the A is not being determined, like that you are saying, ma'am. But if they're asking for this equation, if they're asking about the A value, it is 0. Yes,
A
no.
value means no. We cannot take as 0, right? If we take 0, then we will get simply the x-axis, right? P of x equals to 0, y equals to 0.
Okay, ma'am. But if you're saying, but when you substitute P of x is 0, then the if you want to find the y-intercept, it is cannot be fine. Y-intercept is here is 0, 0. I mean, yeah.
Y-intercept is 0 here.
0,
That is why we cannot get the value of A from this equation, no? Because we will get 0 in both the side, right?
Yeah, ma'am. So ma'am, my question is, for any graph that passes through the origin where y equal to 0, it is not possible to find A, right? So generally I'm just using the word constant here, assuming that I'm saying A is a constant, and if the graph passes through the origin, it is not possible to find A, correct? So that is for any sort of equation.
Not possible will be maybe something wrong. I mean, it's possible, but in that case, and if we take any, in particular this figure, so if we take any negative number, it will satisfy the graph.
Okay.
So we just have to check whether we just have to check the sign of the coefficient in that case.
Okay.
Yeah. So if we take in -2 instead of -1, it will again satisfy the graph, right?
Correct. Okay.
Yeah.
But most probably the coefficient would be 1, plus or minus.
Yeah. So we will consider the simplest thing, right? So we will always proceed with +1 or -1.
That's it. Because if we cannot add any values to the
No
coefficient
need
apart
to
from the
complicate
-1.
it. So we will consider +1 or -1. We just need to determine the sign of the coefficient.
Correct.
Okay, and the sign we can determine from the end behavior.
Excuse me, ma'am. Can you? I don't have doubt in this week up till now, but I have a doubt regarding the previous weeks. Can you please explain one question from week 2?
Okay, so about week 2, I cannot cover it right now because it's already 10. If you have doubt from week 4, I will definitely cover it. But from
understood, ma'am.
from Wednesday or Thursday, we will have two revision sessions, okay? For week 1 and 2 and for week 3 and 4. So in this session, you can, in the revision session for week 2, you can ask your doubt, okay?
Okay, thank you, ma'am.
Ma'am, at which time it will be conduct, ma'am? Revision sessions?
Probably Wednesday and Thursday. Let me check it once.
Is it evening or morning?
Yeah, evening, maybe in the same time. You should have informed about it, no? The class timing.
Yes, ma'am. We get
We
notified
will
in
check
the
Google
calendar.
Calendar, ma'am.
Yeah. Check the Google Calendar. But yeah, Tuesday you have revision session for week 1 and week 2, and Wednesday you have revision session for week 3 and week 4. Okay?
Okay,
thank you, ma'am. It was a nice session. Thank you.
Yeah, welcome. So yeah, if you have any other doubt,
Is it revision sessions for all subjects, ma'am? Like CT, statistics happen?
Thank you.
that I cannot say you. Basically, for each course, like each different course, there are different instructor. So they might be handling it in different way. But for Math 1, you will have a revision session.
Okay, ma'am. Thank you.
Hello.
Welcome.
Ma'am,
Yeah.
what is the paper
Thank you,
pattern
ma'am.
for which one to the maths, ma'am? How are there? How many
So,
points?
okay, roughly said, you will have maybe 2 to 3 questions per week, and the weightage will be almost same from all the weeks. So all the weeks are really important, and the concept covered in the class are important. And if you just practice the assignment questions, all the assignment questions, then we can solve it in the exam also. Like we are maintaining the pattern, and particularly in week 4, just focus specifically on the graph, like from a graph calculating the equation, from a equation draw the graph and turning points and highest, I mean the minimum possible highest degree. So these are all the important thing. So question will be from this concepts.
Ma'am, is
Ma'am,
pattern
for
is same as the graded assignment for the weekly as ma'am?
What? Repeat.
Pattern for the exam, ma'am, is same as the graded assignment for week.
Yeah, kind of same. Yeah. So
exam mode, online offline.
Online, yeah. So you should have in the orientation, maybe we have already given all the information, right? So exam mode is online.
CBT, computer based.
Yes.
And also like people who are not aware, there will be a mock this thing also in the thing that is typical to the this thing, the final exam, the quiz one.
You were in the last semester also, na, in this course?
Yeah. All the
Yeah. I recognize your voice.
Thank you, man. Actually, for personal reasons, I had to come out of this thing. I had to drop some of the things.
Oh, okay.
I had to travel and so on, so I couldn't complete. I just attended only after the quiz one. So I had some.
Ma'am, I have a doubt, ma'am. For
Yes.
qualifier exam, should we qualify in each and every subject, ma'am?
Yes.
If we qualify in any two subjects, will they consider it, ma'am?
I'm not very sure about it, to be honest. So it's not
No.
better to give any wrong
No.
information.
You will
Okay.
have to qualify in all 4.
Hello, madam.
Yeah.
If okay, so if
Madam, just only one small clarification.
Yeah.
Okay, as I'm a working employee, okay, I'm not able to find time about 8 till 8 o'clock. I have to be at my office. Okay, so what is happening is actually I have to sit down after 8:30 and prepare for the examination. The only concern what I have is it good enough to practice the graded assignment which is in the portal to go ahead for the exam, or should I, prepare more?
if you can solve the graded assignment, if you have that much knowledge to solve the graded assignment, then it's fine. I mean, activity questions are not that tough. I will prefer you to go through the practice assignments, because some practice assignments are tricky, and yeah, graded assignment. And if you can like solve the previous year graded assignment, then it is the best way.
Previous year, but I don't know where to get the TYQs I got, but I don't know whether that is an official.
Most of the things are common actually. So if you are solving all the assignments from your batch, it is enough.
Okay.
Like there will be no question from something like some arbitrary concept. All the question are
No,
from
there
this.
are there actually. There are some questions that are there, but there are some JEE questions also. I was able to see actually in the
But you can solve them using these concepts also. So the main thing is you have to be very clear with the concept. If you have any tiny doubts even, you can ask the instructor. Also, there are TA sessions, right? So
the
you
thing
just
is that I'm not able to see actually my working hours. The TA sessions are happening around 2 o'clock, 4 o'clock, like that. I will be at my office.
Okay.
And I'm not able to get that also. See, other subject I'm able to ace it with 80, 100%, even 70%. I'm able to do that. But in mathematics alone, it is if we calculate only, the things will work on. If you don't, it is not like a theory based thing. Correct me.
Okay,
so that is where
actually,
I'm not able to because I start my day by 9:30 and I close my day by 8 night. So that is where I'm after 8:30 I have to sit, and I can go till 12. After that I'm not able to sit all the night. That is the
I
issue.
completely understand your point. But the thing is, if you are not able to attend all the live session, there are recording too, no? So you can go through the recording also. And if you are not getting that much time to, then at least join the revision sessions or the open sessions.
That's what I have to apply for a leave,
No,
and I have to sit at home to because if my company gets into the
no. The revision sessions are always taken by the instructors, and it's from 8. So from 8 you can do that, no?
Yeah, it is 6 to 8 and 8 to 10. I have seen the calendar. It is 6 to 8
Yeah.
and 8 to 10. So
6 to 8 is TA session and 8 to 10 is instructor sessions. So you can join the instructor sessions. Also, if you are not getting this time too, there are Mobius, right? Or like there are some other tools where you can post your questions. So you can do these things. Also, I will suggest you can create a group among the students. You can post your doubts there so that other students can ask instead of you, and then you can clarify your doubt from your friends also. Okay, so these are the things you can do.
That is one final request again from your side. Madam, when you compare this BS degree, that is from foundation to BS, and the diploma, separate diploma, there is a course actually, which is better for a career opportunity, because I am currently working as a product manager in a pharmaceutical company.
Okay, so I'm not the right person to suggest you. So,
Okay,
if
no
any
problem.
of the student has any idea, you can convey. Otherwise, you can ask in the next Vishal will be taking the revision session. Then you can ask him. So I actually don't know that much about it. Okay.
Samantha, I have a request. Today the session, this TA session was cancelled in the last minute, is it? Because actually I was scheduling the day, but only to find that when I reach home, only to see that the session has been cancelled. So I'm wondering, because we didn't get any mail or something in advance about the cancellation.
Okay.
It was from 2 to 4. I was wondering, even I thought my calendar is not updated, so I tried to log in and log out. Even then, maybe then I realized it was pushed to Tuesday or something, if I'm right. So just a request, could you ask your colleague to at least to send a message so that we can plan the day accordingly?
Yeah, sure. I will definitely ask them. Yeah, sure.
Because if we plan the day and we have to rush back, so
Yeah,
only to see that,
definitely. Yeah, I can understand. Yeah, definitely. I can
that will be
understand.
helpful.
Yeah, sure.
One thing,
I will
ma'am.
definitely.
Ma'am, when will the mock quiz will be updated?
Very soon, maybe in the next week, maybe.
Ma'am, week 2 maths is similar, like questions are similar to physics, right, ma'am? It is
Week
asking
2.
acceleration.
Yeah, it may be in your week 2. There was just like it was the starting portion of geometry, no, including your Cartesian coordinates, straight lines, and all. So if you have a problem, you have different approaches. So it can be something from physics. It also there are mathematical
The
approaches.
questions look like a projectile from same, ma'am. In 12th standard, what we studied, so it looks like same physics questions.
Okay, so you all are like comfortable with this physics, like basic physics things, no?
No, ma'am, we
I
are
am a
always
math people
comfortable
too,
to
but
math.
we need to know like just basic about all the physics and especially
Yeah.
physics, not chemistry. Just the basic things, no? Not that much, but only the basic.
Yes.
Ma'am, I have asked a question. Is the paper pattern for the grade, which one is same as the graded assignment, ma'am?
Almost. Not exactly. I cannot say you. I will recommend you to join the revision session or at least just view it once in the YouTube channel because in the revision session we'll definitely cover same type of questions. So I
Is
will
there a
definitely
revision session
suggest
for the
you.
CT, ma'am? Revision live session for the CT course? Because
Uh,
I haven't joined even one live session for the CT, ma'am. Where it will, there is no calendar session timings on that, ma'am.
Not CT, I cannot say you anything. But in our course, there are two revision session. I will like suggest you to join them. If you are not able to join because you may have some other problem, you are maybe working in some company, then also like at least try to view it once in the YouTube channel.
Okay, ma'am. Thank you.
Yeah, and Samruddha, I have posted the previous quiz, the 8th grade link to everyone, the PYQs
Okay.
for the PYQs.
Yeah, yeah. So you can copy the link and you can go through the link. Yeah, please. Thank you for sharing it.
And I think for the math, it's only from
Ma'am,
8 to
is
10.
that previous questions helpful, ma'am, for this exam?
Yeah, definitely helpful.
Oh,
There may
thank
be some direct question from previous year. Maybe. Not sure, but maybe. So any other doubts?
Some secrets are coming out now.
Ma'am, is there a negative marks, ma'am?
No, not. I'm not sure, but yeah. So far, what I know, there is no negative mark.
Well, I think there was always a question like people. I think even the graded assignment also we have the same thing. Even if you mark one right and one wrong, obviously you won't get a mark for that. It's the same thing in the exam also. Even if you have chosen the right one in the multiple choice, but you have chosen another wrong one, obviously you won't get a score. It's not a negative, but you won't get a score there. That is the only negative point that you have in the exam, as well as in the GA.
Yeah. So it is a basic rule for multiple select questions. No. So
Yeah,
all the
that's what I want to
options
say.
have to
I
be.
mean to say that is the
Yeah.
only negative thing that we have it here. Otherwise,
Yeah, so this is the same rule in all the exams. So there is no part marking actually.
but in I don't know, but in start sometimes they are giving a partial mark, but sometimes they are not giving. I don't know how it works. Even I didn't want to get into that thing so
Okay,
complete,
then
so I just left it.
maybe it depends on the value. I'm not that sure about the stat team, but in math, there's
It's not.
always.
It's also not standard. It happens sometimes. It happens. Doesn't happen. So
Yeah,
I don't want to get into that. I also left it.
I don't want to make any comment about the stat team, but yeah, for maths it's fixed.
Okay. So can I take
Yeah,
leave?
yeah.
Thank you.
Yeah, welcome.
Thank you
Any
so
other
much.
doubt? Yeah. I mean, regarding the question, regarding the concept, if don't, you can leave also. You can ask if you have. So the final suggestion is go through the previous year questions and solve the all the assignments. and just check the revision sessions. So,
Ma'am, I have a doubt, ma'am. In revision sessions, will you cover each and every topic from week 1 to week 4, ma'am?
yeah, yeah.
Okay.
Probably, if you have doubt with some topic, then you can like clear with the instructor. Also, there will be like problem solving things. So if you have some problems still left in your
And in
diary,
revision session, will you brief the theory, total theory, ma'am?
it depends on the instructor. So I'm not going to take the revision session. So even like if you want the total theory, you can ask the instructor, then they will briefly describe you. Or if you have problem with some particular things, then you can ask this also.
Okay, ma'am.
Yeah.
Sorry, I forgot. Tomorrow you will take the session?
Yeah, tomorrow I will take the session. Open session maybe. Yeah, open session.
From 8 to 10 again, right?
Yeah, from 8 to
In
10.
that session, will you discuss the questions, ma'am?
Yeah, all possible question, your doubt, all the doubt I will pick, and also I will solve the question. That's it. I will
Regarding
not
fourth
assign
week, ma'am?
Yeah, regarding the 4th week, yes.
Okay, ma'am.
Yeah. Okay, so if you have further doubt, you can ask. Otherwise, you can leave also.
Thank you. Good night.
Yeah, welcome. Okay, so I guess you don't have any other doubt. So we can close the session maybe with all of
Ma'am,
your permission.
actually,
Yeah.
I don't have any doubt, but I have a problem. Like, I've got a invite from Discourse forum, and I somehow missed that in September only, and now it's expired. So I need a re-invite so that I can join. If you want, I can provide my student email ID to you.
Okay. Can you mail you with your email ID and with your problem?
Mail to whom, ma'am?
You know the official email ID for Maths 1?
No.
Okay. So you can also mail it to my personal email ID.
Okay, can you write it in the chat box?
Yeah.
Yeah, okay, sure, I'll do that.
Okay. So yeah, I have written it in the chat box. You can mail me this with this problem. Oh, sorry, it will be IIT, not Y. Okay. Please rectify it.
Oh, okay, ma'am. Okay, sure.
Okay, so fine. I guess you don't have further doubts. So
I
we
have
can.
one doubt, ma'am.
Yeah, okay. Sure.
When
Ask.
will be the paradox, ma'am, regarding to IIT?
Right now I don't have any information about the paradox.
When will be it, ma'am? Like after qualifying the qualifier examination or a foundation level, ma'am?
Actually, I'm not really sure about it, so I don't want to make any wrong comment. So better you can ask someone else about this. So I don't have that much information.
Thank you, ma'am. Have a good day. Good night. Bye, ma'am.
Yeah. Good night. Okay. So good night, everyone. We can end this session.
Good night, ma'am.
Yeah.